Good evening, everyone, and welcome to our new An Evening with remote meetup. We are happy today to host a very famous international speaker. I'm talking about Mr. Scott Wlaschin, author of the book Domain Modeling Made Functional, and of course, of a workshop with the same title that we will be hosting next month. Hello, Scott.
Hi, how are you doing? How's everyone doing?
Excellent. Thanks for being with us, Scott. So as said, Scott will be presenting his talk titled Domain Modeling Made Functional, which is about to start. Let me just remind you that you can ask your questions using the live chat on YouTube. We will be reading the questions every now and then to keep the talk interesting and, of course, to answer your doubts. I think that is it. Oh, wow, we have guests from Texas. Yeah, excellent. Cool. I think that is it. Over to you, Scott.
All right. Well, hello, everyone. It's nice to be here. Nice to be in Italy. So, yes, this is Domain Modeling Made Functional. My name is Scott Wlaschin, and that's my Twitter handle. I had a hard time grabbing that one, but I'm glad I got it. So FSharp for Fun and Profit is my website, and I will be using FSharp examples here, but this is not really a talk about FSharp. This is a talk about the functional approach to domain modeling. So normally people that think of functional programming and domain-driven design as two completely different things. Domain-driven design is considered like object-oriented and non-mathematical, and functional programming is kind of weird, but I actually think they are a perfect match. They really are a great way of working together. So again, it's not just good for mathematical things only. I think functional programming is great for interactive and collaborative domain modeling and representing a domain model accurately. And this is what this talk is all about. Hopefully by the end of the talk, I will have persuaded you that this is true. So before I talk about domain modeling, I want to talk about design. I think this is something that we kind of underemphasize in programming. If you think about software development, it's a process like anything else, and there's an input, and there's an output, and there's something in the middle where you do the work. We love to focus on the middle bit. We like to talk about programming languages and editors and IDEs and frameworks and testing and all this other stuff. And that's all the process. But there's a very famous phrase of garbage in, garbage out, which means if you have bad things going in, you're going to have a bad output. And no matter how good your programming language, no matter how good your unit tests, if you have bad input to the process, you will almost certainly have bad output. So if you can reduce the amount of garbage in, hopefully you get reduced garbage out. So reducing this bit is really important. And that's what I would call design, everything to do with what you do before you start coding. So basically thinking, all the thinking you do and all the talking you do before you actually start implementing. So what is the best way to do this kind of thing? And there's lots and lots of ways of doing it. I like to borrow from Agile and domain-driven design. And from Agile, the main thing I take away from Agile, because we're not doing object-oriented stuff, so a lot of that stuff doesn't apply, but the thing I really take away is this rapid feedback. The idea is you don't wait 6 months to deliver something. You try and get feedback as soon as possible during the process. And in this case, we're getting feedback during the design process, not getting feedback during the implementation process. And from domain-driven design, the whole point of domain-driven design, I mean, there's lots of technical jargon around it, but from my point of view, the most important thing is that everybody involved in the project has a shared mental model of what the system's supposed to do and how it's supposed to work. And not only do the users, not only the people involved, but also that's also in the code. So here's a little picture. And we have this shared mental model in the middle, and everybody involved in the project shares that mental model. The developers, the product owners, the domain experts, the users, the customers, the user interface people, testers, anybody, they all share the same mental model and they all use the same language. And this is the most important thing. If everyone is using the same concepts and the same language, if people don't have the same language and the same concepts, I actually find that that is a very strong predictor of a project failing. So again, in my experience, it's nothing to do with which programming language you're using. It's really to do with, are people talking to each other, and are people using the same ideas? So that's the most important thing. And having the code be part of this is also really important, because the code acts as documentation, it acts as the domain model, and rather than having in a separate thing, or just people in people's heads but never written down, or written down but written down somewhere the way you can't see it, if it's in the code, that's a great place to have it. So the common language should be in the code as well as in people's heads. There shouldn't be a kind of translation between developers' heads and code. Now, most people, when I start saying this, most people say, well, that's nice, but can you really make the code represent the domain? I mean, is that even possible? Because this is what code looks like. We all know this is what source code looks like. Actually, non-developers think source code looks like that, and maybe some C developers also think this is what it looks like. Let me show you what I think domain-driven source code looks like. Okay, so you have to guess, what is this domain? You know, this is FSharp code, which you probably don't know, but hopefully you can guess what the domain is. So yes, I think it's something to do with card games. It actually said card game right at the top. The things down the side, this is the shared language. The card and a hand and a deck and a player and a game. These are all the concepts in the language, and they're all in one place. And let me just explain FSharp syntax very quickly. Vertical bar means a choice. So a suit is a club or a diamond or a spade or a heart. When you see a little star like that, that's a pair. So a card is a combination of a suit and a rank. In FSharp, we have a list type built in. That's very nice. And when you see these arrows like this is a function. And the input is on one side and the output is on the other side. And I'll be using these kinds of functions to represent verbs, not just nouns in our domain, but verbs in the domain, activities, use cases, stories, workflows, whatever you want to call them, but things where things change, where activities happen. So let me just go into detail about how you would actually model an action using a function. So let's say we want to model dealing a card. So to deal a card, the input is a deck of cards. And the output is two things. It's a card on the table, but it's also what's left in the deck after you've dealt the card. So it's basically the original deck with a card missing. In functional programming, everything is immutable. So we don't mutate the original deck. We make a copy of it with the card missing. And that is, this is basically how we do things in functional programming. So as a result of this way of thinking, the deal function, the output is a different thing from the input. And in FSharp, we'd write it like this. We say to deal, the input is a deck, and the output is a pair of things. It's the modified deck, or the deck with the card missing, plus a deck, plus a card on the table. So this is how we represent the action of dealing a card using a function. Now, to pick up a card, it's very similar, except this time we have two inputs. We have, you're holding a hand, and there's a card on the table. Those are the two inputs. And after you've picked up a card, you now have a new updated hand, and the card on the table is missing. And again, you can't change the original hand, you have to mutate it. So we would write it in FSharp as a pair. The input is a hand and a card, and the output is a hand. So again, this is another verb documented as a function. So here is the card game domain written in code, in FSharp code. And the first question is, do you think this is a reasonable amount of code to write for this domain? And I think the answer is yes, because the whole domain fits on one page. We've got 9 different concepts on one page. We don't have to go to 9 different files. And this is a relatively simple domain, but even in more complicated domains, I've seen, there might be 5 or 6 pages tops. It's very, very condensed way of documenting things. So another question is, do you think a non-programmer could look at this and understand it? And the answer is yes, because I've actually done this with non-programmers like product owners or domain experts who are not developers. And they say, this is great documentation, and where's the code? They don't think this is code. It doesn't look like what they think code looks like. But this is, in fact, FSharp code. So that's very nice. Much more important is, do you think non-programmers can provide useful feedback? Because the whole point of this is to get feedback from the domain experts. And do you think they can do that by looking at this? And in fact, there is actually a deliberate mistake in this code. I wonder if anyone can see what it is. And this is, I just want to demonstrate that even if you don't understand FSharp, even if you don't even understand development, you can probably see that the ace is missing. And this is the kind of thing that I've actually got real feedback from people when I'm doing domain modeling from experts, and they say, yeah, you forgot this particular case or this particular choice, and we just need to add that to the design. Now, that's very nice, but I want to talk about rapid feedback now, which is the whole idea of getting feedback in minutes. Feedback, the faster the feedback cycle, the better things are. And so the agile thing is, you get an implementation and you get it out there as fast as possible to show people. If you can get feedback in minutes rather than days, that's even better. So in the design stage, you can do that. And I'll give you an example of how this works. So here is some happy people doing collaborative development on a whiteboard. This process of building a shared mental is an interactive process. It's not something you just do at your desk. And as I said, it involves everybody, all the stakeholders, everybody who cares about the project should be part of it, not just developers. So you get everyone in a room, just like with event storming, all these other things, everyone's in a room and you write this code collaboratively. And part of this is you learn, it's not just about getting the answer, it's about learning about the domain. Ideally, the developers become domain experts along with the real experts. So I'll give you an example. Here is me typing, a deck is a list of cards, and you to deal, you start with a deck and you have an output of a deck and a card. And at this point, the domain expert might stop me and say, that's actually not right. We don't deal with a normal deck of cards. We have something called a shuffle deck. This is what we deal with. So immediately, I can interactively update the design like this. So I say, is that right? You start with a shuffle deck, and the output is a new shuffle, the shuffle deck with a card missing and a card on the table. And they say, yeah, that's right. Okay, so now I ask a question. I say, what's a shuffle deck? Because I'm not an expert in card games, so I need to understand how this works. And the expert says, well, it's a list of cards. So I document that. And it's really important that I document it as a different concept. If I say, is the shuffle deck the same as a normal deck? And they say, no, it's a different kind of thing. So they both are represented by a list of cards, but they are different concepts in the domain. So I should not represent them as a list of cards with a Boolean flag or a base class with two subclasses. That is the wrong way of doing it. They are different concepts. They have the same representation, but they're different concepts, and they shouldn't be mixed up. Okay, so now I've learned what a shuffle deck is. My next question is, well, how do you make a shuffle deck? And the expert will say, well, obviously you just do a shuffle. And this is the kind of thing I'm trying to become, as a developer, I don't know about the domain. I'm trying to ask lots of questions about the domain and become a sort of domain expert myself. So I've now learned that this concept of shuffling a deck, which I didn't know about before. And you start off with a normal deck and the output is a shuffle deck. Okay, so that's all good. So this is how the design process happens quite quickly. We're not writing any code. We're getting lots of feedback for the domain experts, and this becomes documentation as well. So here's the final version with the new shuffle deck added. And again, I want to stress this is domain driven. It's not database driven. There's no foreign keys. There's no tables. The domain driven design, people have a word for this, which is persistence ignorance, which is how the stuff gets stored in a database or the file system or whatever. That is not normally part of the domain. Obviously, it's important in the implementation. You need to store things at some point, but that shouldn't drive the design of the domain. That's just an implementation detail. The domain normally doesn't care. Like playing a card game, you don't care about how the stuff is stored, whether it's in a relational database or a document database. That's not part of the domain model. This is not object-oriented either. There's no base classes, there's no managers, there's no factories. Every single concept that you see is part of the domain. There's nothing extraneous. And I just really want to stress this, because in the real world, we have these concepts, and we want to basically have the same concepts in the code. The domain code should be representing the real world. It should be in sync with the real world. And if we learn new things about the domain, like a shuffle deck and so on, then we need to represent that in the code as well. So the code always represents the real world. Now, what we don't want to do, that's the right way of doing it. What we don't want to do is the other way around, where we have jargon in the domain. Like, let's say we need some way of managing the players, so we have a player controller. Or we say we need 2 subclasses, so we need a base class. Or we have an abstract card proxy factory bean or something. This is bad. So if you see the stuff in your domain, you're doing it wrong. Now, obviously, in the implementation details, the code can get very ugly, but that's not part of the domain code. That's part of the implementation code. So in this approach, the design and the code are the same thing, which is a great thing to do because the code never gets out of date. Documentation gets out of date. UML diagrams get out of date. The code is always a source of truth. So if you can capture the domain using source code and you store it in the same Git repository and everything, that's great because they always stay in sync. This is not pseudocode, this is executable code. And in an FSharp project, this would typically be the first file in the project. This is kind of sets up the project, and the rest of the code, the implementation code, references this file to, to use the kind of design. So if you change this file, if you change the domain, the rest of the code doesn't compile until you make it be in sync with the domain logic. So again, it's not about the result. It's not just about the result. It's about the process of getting everyone on the same page, the process of building a shared mental model, the process of building shared vocabulary. It's not the idea, this is not about creating the document. The process is just important. Collaboration is the important goal here. So communicating the design in the code is a key domain-driven design principle. So I'm going to give you a little challenge, and then we'll just take a little break to ask questions. So while we're having a break, you can think about this. Here is a contact design, and it's got a first name and a last name, and this is FSharp code, and it could be, JSON or something. And do you think the design is communicated in this code? So for example, which values are optional? Like the middle initial, maybe that has to be optional, but the other ones are required. It's not at all clear from this code. It might be done in some validation logic somewhere, but it's not clear from this design. What are the constraints? So the first name, can it be 1 billion characters long? Can it contain non-printable characters? There's almost always some sort of constraint on things. And again, there might be some validation logic somewhere, but it's not here. So let's say at some point you need to print it out on a mailing label, so it can't be more than 50 characters long or something. And there's some domain logic, like this email verified flag. It should only be set to be true if you've verified it. So if you change your email, it has to be set back to false. But that's not at all clear from here. So all these things are not communicated in the design. So all these 3 things, now it turns out that you can communicate them in the design with functional domain modeling, and the rest of the talk, I will show you how to do that. But before I go on to the next section, let me just pause and see if anyone has any questions at this point.
Okay, thanks, Scott, so far. Yes, we do have a questions from Moreno asking, what if business experts are not Anglophone? Should we use their native language in code or just stick to English?
That's a good question. Hopefully, I would use, that's a very good question. I personally would say use the language. If the developers are Anglophone and the domain experts aren't, hopefully I would recommend the developers and the domain experts speak the same language and use that language in the code. I think that would be a good idea. Just because it's easier. The idea is that someone else comes along, like this card game example. If you have a new person on the team and they join the team, by looking at the code, they can understand the domain and talk to people using the same words that the experts use. So ideally, you should be using the same language, and that the domain experts are using in both senses of the word. So, but I don't know. I've never actually had that situation. Yeah.
Okay. We do have another one. Thanks for that. By Alex. With the domain language modeled in FSharp, like you just showed, and the fact that implementation code won't compile if they aren't in sync, does that mean your code is naturally tested to some degree?
Yes, absolutely. And I'll be showing you that where you literally cannot write certain situations, you cannot even implement certain things because it won't compile. And that's a really powerful technique. So it eliminates a lot of the unit tests that you might have to write because certain things literally can't be compiled. And that's, yeah, it's a very powerful technique. And I will be talking about that shortly.
Excellent. Thanks, Scott. Looks like we are all good for now.
Okay.
Although we do have a 10-20 seconds delay between Zoom and YouTube, but there will be more breaks. So please keep the questions coming and let's carry on. Okay.
So that's where we are right now. This is think about this challenge and see how you would do this in such a way that you can communicate the design decisions in the code without having to look at documentation, without having to look at any kind of validation logic. And I will give you the answers in a few minutes. Right. So in order to do that, we need to understand how functional programming works a little bit, and why I think that functional domain modeling is actually more useful than object-oriented domain modeling, which sounds kind of surprising. So the first thing about functional programming is that composition is the key principle. Everything in functional programming is about composition. And if you're not familiar with what that means, that is basically using Lego. So if you know how to use Lego, you know how to do functional programming. And here is some Lego. And the thing about Lego is you can build big things from small things. So here is building big things from small things. Here is a piece of Lego that is built from small things. And that is composition in practice. You just keep adding smaller things together until you get something big. And Lego is designed to work that way. Every piece is designed to connect to every other piece. So in fact, you could take two of these things and connect them to make one which is twice as big. So in functional programming, we have this thing called an algebraic type system. And I prefer to call it a composable type system because composable meaning you can use them like Lego. So in functional programming, we can build types in two different ways. We can use and we can use or. And I like to use and or because these are the words we use naturally when we're talking. So let me show you what I mean. Start with and. So if I want to model a fruit salad, this is a pretty bad model, but let's say I want to model a fruit salad. I need one apple and a banana and some cherries. So in FSharp, we'd write it like this. A fruit salad is an apple and a banana and a cherry. So I'm using the word and. Okay, and in FSharp, we call this a record type. But basically, this is something you're familiar with. It's a struct. You know, it's not exactly a class, but it might be like a DTO or something, a very simple object. And the colon, after the apple, there's a colon. It means apple variety. It means if it is an apple, in the apple case, all the possible apples it could be. So it could be an int or a string, or in this case, one of the apples. And so this is something you're familiar with in any programming language. Anytime you have a pair or a tuple or a record or a struct, this is what's going on. Now, the other thing we can do in a compositional type system is use or. So if I want to model a snack, I would say it's an apple or a banana or a cherry. So I'm using or now. And in FSharp, we write it like this. A choice type is an apple or a banana or a cherry, and there's a vertical bar now. And if it's an apple, it's one of the apple variety. And if it's a banana, it's one of the banana variety. Okay. So you can think of this as kind of like an enum a little bit, maybe. It's an enum with extra data for each case. And this is the kind of thing that's not normally available in a non-functional language. Like Rust has it, TypeScript has it, but most languages do not have this kind of thing. So let me give you a real world example of how this actually works. So let's say you have requirements to model a payment and you take cash, PayPal, or card. Now for cash, there's no extra information. For PayPal, there's an email address. And for cards, we have a card type and a card number and an expiration date and a security code and all that stuff. So how would you implement this if you were going to implement it. Now, if you're an object-oriented person, you probably have a certain way of thinking about it. So let me show you how I would do it if I was doing it in an OO style. I would probably start with an interface like this. This is C# code. Java would be similar. Or you could use an abstract base class or an interface, and then you have basically subclasses for each of the choices. A cache subclass or a cache implementation and a PayPal and a card and so on. So that's kind of the OO way of doing things. Now, in the functional programming way, we build things up, bigger things from smaller things, composition. So we're going to start with the small things, the primitives. And because we're doing domain-driven design, we're not going to use string or int. We're going to use the same words that the experts use. They don't call about strings. They talk about email addresses or card numbers. So the very first thing we do is model primitives with words that actually mean something in the domain. And then we have our first choice, a Visa or a MasterCard. It's a choice. And then a credit card information is a card type and a card number and, whatever, but I'll just keep it simple for now. So that's an and. So we have a choice using or, and we have a record using and. Okay, and then we keep going. So now we can get to our payment method. We can say a payment method is cash or PayPal or card. So it's or, and therefore it's a choice. And some of the choices have information. So in the PayPal case, we have an email address, and in the card case, we have card information. And then we don't have to stop. We can keep going. We can say, let's do another primitive. Let's say a payment amount is a decimal, and a currency is a choice between euros and dollars. Okay, and then we can say, okay, finally, a complete payment is an amount and a currency and a method. And we can keep building, we can add and add and not. So we're building smaller things from bigger things. So our final one is an and. Building bigger things from small things is composition. It's a Lego approach to designing things. So hopefully that makes sense. So let's look at the example I gave you, and let's see how we can fix this with composable types. Okay, so that contact, we're going to refactor that contact using this approach. So here's what we had at the beginning. And to be honest, this looks very suspiciously like database-driven design. This looks like a database table to me with 5 columns. And that is not how the domain experts would talk about it. Okay, so let's make it domain-driven design, not database-driven design. So the first thing we say is when we're talking to an expert, they'll probably say, well, a contact has a name and some email information. So I say a contact is a name and email. So it's an and, so it's a record with 2 fields. Okay. So I say, is that right? To the domain and say, yeah, okay, that's good. All right. So we have 2 new concepts already that we didn't even start. We know these are concepts in the domain that we didn't even think were important. But now we have them. So let's say, okay, so what's a personal name? Okay, so a personal name is these 3 fields, or these 3 things: a name and initial and a last name. And this is a very American thing, by the way. I'm sorry for Europeans that don't always do this, but this is like, I use American examples because most people are American. Most people who listen to my talks are American anyway. Okay, so what's required and what's optional? Like I said, the middle initial is optional and the first and last name are required, but again, it's not at all clear. So what we want to do is make it very clear that the middle initial is optional. So how can we represent optional values? Now, what we don't want to do is use null, because null is a terrible thing. We actually want to represent it using our type system. So modeling optional values actually turns out to be quite straightforward, because when we say something's optional, we say it's either something, there's some data, or there's nothing, right? There's something or nothing. So that's a choice. So we're going to model it as a choice between 2 things. So some choice is in what is either something or nothing. And in the some case, there's some extra data that's the actual valid data. And the other case, there's no extra data. So that's how we think about it. Now in FSharp, we actually write it slightly differently. This is how you write it in FSharp, because the data could be anything. So we're going to use a generic type. So if you're used to C# and Java, you've seen this syntax, the angle brackets with a T to mean a generic type. In FSharp, we have a little tick in front of the T, but otherwise it's very similar to C# and Java, how you do it. So now we can write our personal name with an option like this. And now it makes it very clear that it's optional. And what we say is anything which isn't optional is automatically required. So the first name and last name have to be required. And in FSharp, we can actually put the option afterwards, and it makes it a little more readable. I think that's, if you're showing it to non-programmers, I think it's a bit more readable this way. All right, now the next thing we have to worry about is simple values and constrained values. So what do I mean by that? So a simple value is something like a string or an int or date or something, but we should avoid primitive obsession, which means using strings and dates in our domain. The experts do not talk about strings and floats and dates and ints, right? We should not model them that way. I mean, once upon a time, I was talking about something being a float, and one of the people involved said, does that have something to do with water? I mean, you know, and fair enough, that's a very good question. Why does float mean anything to do with numbers, you know? So don't use those words. We want to use domain-specific words, right? And not only that, it's very rare to have a completely unconstrained int or a string. Is it common? I mean, when was the last time you had an int that could go up to 2 billion or 4 billion? When is the last time you had a string that could be, you know, a billion characters long or have non-printable characters? It's very, very unusual. So something like an email address, you know, at least it can't be empty and it has to have some sort of pattern, at least having an @ sign in it or something. A phone number can't be an empty string. It has to have some sort of pattern. It probably can't be a billion characters long. Even something like a customer ID that's an int in a database, it has to at least be a positive integer, right? If it's a negative integer, it's probably an error. So an email address is not a string. And a customer ID is not an integer. And not only are they represented by them, but they literally are not the same as a string. I mean, if it was a string, you could concatenate two strings and get another string. But if you concatenate two email addresses, you'd never do that. You'd never have a concat for email addresses. You'd never reverse an email address or take a substring, you know, it just doesn't make sense. And similarly, a customer ID, can you multiply it by 42 or take the square root of a customer ID? I mean, it's not an integer. It might be represented by an integer, but it isn't actually an integer. There's the kinds of things you can do with it. You know, you can't add 1 to it. It's not an integer. Okay, so don't represent it as an integer in your domain. So we want to, how do we capture these things? Well, we use a wrapper type, and this is how we do it in FSharp. We say we're going to wrap a string in an email address, and we're going to wrap an int in a customer ID. So that's the wrapper bit right there. So if you see that, that's us making a wrapper type. And here's a one for string 50. Okay, the string 50 is not just a normal string. It has to be, it's constrained in some way. So we're going to wrap it in a string 50. And what's nice about this is when you start doing this, you end up with distinct types. And it makes it very clear that an email address and a phone number, if we wrap them, they are no longer strings. They are separate types, and the compiler will not let you mix them up. Again, a customer ID and an order ID, if they're both integers, they now become distinct types. So there's really two benefits to this. First of all, it's much clearer from a documentation point of view. The code becomes a lot more self-documenting. The domain modeling becomes much more clear. And also, from an implementation point of view, it stops you making stupid mistakes where you mix them up. So an email address can never be passed into a function that needs a phone number. And an order ID can never be passed into a function that expects a customer ID, because they are completely different types, and you will get a compiler error. So you get two benefits in one go, which is very nice. Now, a question people say is, how do I implement the constructors for these things? How do I guarantee that the constraints are met? So let's look at creating an email address, for example. So if I create an email address, you give me a string, and if the string contains the @ sign, then I wrap it in an email address. And if it doesn't contain the @ sign, what am I going to do? Well, I'm not going to return null, because that's bad. And in fact, in FSharp, you can't return null because things aren't allowed to be null. Am I going to throw an exception? No, it's bad. If you think about it, if I threw an exception and I looked at the function, it would say, you give me a string and I'll give you back an email address. And that is actually a lie, okay? Because sometimes I give you a string and I don't get back an email address. So this is bad documentation. We try not to write stuff like this in a functional way. We want to make it much clearer, much more explicit what's going on. So what I do instead is do something like this, where would use the option type to say, well, if it is valid, it's something, and if it's not valid, it's nothing. And then if I look at the signature, it says, you give me a string and I might give you back an email address. If you give me the right kind of string, if you give me the wrong kind of string, I'll give you back nothing. So this is much more explicit. It tells you up front that this function might not work. And people say, well, what if I want an actual error message? Then I use a different kind of choice type. There's another choice type typically called results, where it's either success or failure. It's either something or an error message on the other case. And if you want to say, how do I guarantee that people are forced to use this constructor? Well, you do that in the same way that you do in OO, which is you make the actual constructor private and you force people to go through like a public factory method or a public static method, however you want to call it. So it's just the same way you do it in any program language. Here's another one, string 50. We're going to make a wrapper around it. And then we want to create it. If the length is less than 50, that's good. Otherwise, it's bad. And again, if I look at the signature, it says, you give me a string and I might give you back a string 50 if it's a valid input. Otherwise, you get back nothing and you're going to have to deal with it. Here's another one. If I have, this is something like from an e-commerce website. What's wrong with this picture is that I have like 1 million items in my shopping cart. And this should never happen. I mean, I very much doubt that you can buy 1 million items on Amazon. So the problem is that someone who's designed this has used an int to model the quantity. Okay, that's bad. How do we fix it? Well, we're going to create a new type just to model the quantity in the shopping cart, a new wrapper type just for this domain. And people don't normally do this because it's a lot of work. But in FSharp and Haskell and stuff, it's literally one line of code. So it's very easy to do. So we tend to do this a lot more. And then if we look at the constructor for this thing, we'll say if it's greater than 0 or less than 99 or whatever, that's all good. We create something or nothing. And we look at the signature, it says, you give me an integer and I might give you back an order line quantity. So again, it might not always work. And what's interesting about this design is that in particular, if you give me 0 as an input, you get nothing back. And that is a great way of enforcing some safety checks. So if you have one of those buttons that decrement the amount of in your basket and it goes from 2 and it goes down to 1 and it goes down to 0, as soon as you get to 0, you can't create one of these things anymore. And so therefore you literally can't keep going. So you're going to have to make a decision about what to do. So maybe you're going to remove the item from the shopping cart, or maybe you just ignore the decrement and just leave it alone. But whatever it is, you can't forget to handle this case, because you literally the compiler will not let you have it go down to 0. So there's a whole class of bugs where you have 0 things in your shopping cart or negative numbers in your shopping cart. Those bugs cannot happen in this design. So let's look at after the first refactor. Let's see where we are. This is what we started with. Okay, and we started using the option type for missing values. That was good. Okay, and then the second thing we did is we used wrapper types instead of primitives. So a string 50 and a string 1 and an email address. So no longer strings, and strings are now wrapper types. We now have these two different concepts: a personal name and email contact is now different information, right? And that was something we learned about. This is a very important concept in domain-driven design, which is you have consistency boundaries where each of these things could be updated independently. So they become consistency boundaries. They do their own checking. But if you try and update that, one person's updating the personal name and someone else is updating the same personal name, that's a concurrency error. This is a great, these things are not only concepts in the domain, but they also implementation-wise, they set your units of consistency, which is nice. Okay, so before I move on to the next bit, we've got one little thing that we haven't worried about, which is this Boolean flag, this email verified flag. But I'm just going to stop again and ask if anyone has any questions.
Okay, so yes, we do have one from David. I think it refers back to when you were using the fruits example.
Okay.
And he says, how would you model a choice like A, B, C, pick? I guess if you have to pick 2.
Oh, how do you pick 2 out of 3? Something like that.
I guess.
Yeah, that becomes harder. I will show you in a minute a variant, but you can't model everything. And I mean, a good example is the card game that I showed you. You can't model the rules of poker in that thing, you know. So, but what you can do is you can capture the concepts and you can capture a lot of the ideas, a lot of the vocabulary, but you can't get too far into the details of what's, for example, in the card game, trying to represent all the possible valid poker hands, that would be quite hard. So I wouldn't bother at that point. But I could have a thing where it says a function which says, is this a valid poker hand? Or, you know, what is the value of this poker hand? Things like that. But you can't try and model everything. That's probably overkill. The idea is that there's a trade-off between how complex your model is and how, you know, how hard it is to maintain. So it's I would just basically, even this is better than probably what most people are doing. I would leave it like this. I wouldn't get too much more complicated than this.
Okay, we have other two. One is from Stefano, who says, when I have a complex type with a deep composition of types, can this be a problem? So basically, what is the limit of composing types?
You can keep building.
If I get it right.
Yeah, I mean, you can keep building bigger types and smaller types. I mean, a functional application is basically like this all the way up to the top. I think, I mean, there's probably some sort of limit in terms of how deep you can go, but it's quite common to go pretty deep. I don't think there might be a limit of, like, you know, 100 or 200 levels deep of stuff, but so, you know, this is the fundamental principle of doing anything. Again, if it's too complicated, there's a balance between trying to capture everything in the code. It gets too complicated, and so there's a fine balance. The idea is really as I say, it's a tool for communicating, not a tool for trying to model everything exactly with mathematical accuracy. Because programming, at some point, if you know, there's that joke, if you try and model, if your domain model 100% represents everything that can happen, then at that point you have code. You don't have a design, you know, because that was the idea people had a long time. It's like, if I can have the perfect domain model, I could generate the code from the domain model. Well, if you have the perfect domain model, that is the code, because you're just specifying everything in such detail that you wouldn't need to write any code. So one way or another, you know, it becomes harder and harder to do this. So there's a nice fine balance between the basic concepts and then the detail that would actually, yeah, there's always going to be some detail in the implementation.
Okay, thanks, Scott. We have other two. One is from João Pedro, and he says, when working with discriminated unions in FSharp, is it possible to create methods that accept just one of the types as the parameter? Or do I have to use pattern matching and check my type use records?
Yeah, no, you can't, because the discriminated union is a single thing. So it's not like having two subclasses where they're individual things and you can work with them separately. In other languages like Scala, the cases are separate and you can work with them, but in FSharp you can't. It's one single thing. So the way to do that is to actually create special objects for the two subcases, for the two cases. I will be talking about that right now when I talk about the verified email. And it's if they have distinct behaviors, if the two different cases have distinct behaviors, then the best idea is to create two separate types for those things and then work on them separately. And I'll be demonstrating that shortly.
Okay, last one is from Arnaud, and is string 50 kind of arbitrary for a first name?
Yeah, it is. And another comment is people saying, well, also, you know, you may be there's outside stuff like storing it in a database or something that is contaminating your domain, because how you store it in the database, as I said, you really shouldn't be part of your domain. So yeah, this is a kind of maybe a bad example. There's always some sort of constraints on a first name. At least you could have something called, almost always it's going to be you have to print it out at some point. So a name that's 1 million characters long is not likely, and a name with non-printable characters is probably wrong. So you could just have a thing called a name, and maybe it's less than 500 characters, and maybe it has no non-printable characters, but it's not a specific length like 50. So that might be a better way of doing it. Or, you know, you can maybe just make it a string and just say, you know, it's not a problem. We don't really run into this problem, and I don't care that much. So as a balance, I'm not saying you have to be 100% rigid with this. It's all about communicating and picking your battles. This one might not be worth making a fuss over, but I think email address is definitely worth making a fuss over. String 50 might not be worth it. So.
Okay, excellent. Thanks, Scott. And with so much anticipation on what's about to happen, over to you again.
All right, so next bit. So the last bit is this email verified flag. I'm going to talk about this. And my rule of thumb is if you see a Boolean flag, that is a design, a code smell or a design smell. Boolean flags are almost always bad. So here we have our Boolean flag, and how are we going to handle this thing? Like I say, one of the problems with it is that anybody can set it to anything, and that could be a bug, it could be a security breach even. And you can say, well, you know, we have some other code that checks it, or you read the documentation before you set it. And it's like, that's really bad. I want to have that in the domain logic, okay? So in this case, we would have, let's say, some business rules. If the email has changed, the verify flag has to be set to false because it hasn't been verified yet. And the only way you should set it to be true is if the email address has been checked by a special verification service. So you get your email, you get a verification email sent to you. You click on the link, and it checks whether the email matches the hash that you were sent and all that stuff. There's a special service that does that, and that really should be the only service that's allowed to set this to be true. And if you try and set it to be true any other way, you shouldn't be allowed to do that. So how can you enforce these business rules in the design? Okay, this is bad design. Anyone can set it true, and it's not very clear what the logic is. So let's talk to the domain experts. Okay, so the first thing, if I'm talking to them, they say, well, an email address is either verified or unverified. Okay, they're using that word again, or. So I'm going to model it as a choice. It's either unverified or it's verified. Now, in the unverified case, we can use a regular old email address because there's no danger in making something unverified. We can't do anything bad in that case. Now, what about this verified case? So in a normal, we can use a normal email, but in the verified case, let's just ask the domain expert again. What is it something special or not? Let's ask a domain expert. So I say, is a verified email different from an unverified email? Are there different rules, business rules around verified emails and unverified emails? And they will say, yes, they're different. They can't be mixed up. For example, if I'm sending a password reset, I should only send it to a verified email. So there's a special rule. I really want to keep track of them. I don't want to mix them up by mistake. So that tells me I need to create a wrapper. I'm going to create a wrapper around another wrapper. So you can never have too many wrappers. There's no problem that can't be solved by wrapping it in another type. So by wrapping a regular email, I now have a new thing called a verified email, which is different from a normal email, okay? And so I put that in that slot. So in the unverified case, the associated data is a regular email, and in the verified case, it's this special wrapper type called a verified email. And just like when I had the shuffled deck and the unshuffled deck, they were two distinct things, even though they both were representing a list of cards. Same thing, an email address and a verified email, they're both, behind the scenes, they're both just email addresses, but they're different concepts in the domain, and I'm using different wrapper types so they can't get mixed up. Okay, so that's very, very important. So, and then I say to them, well, where do we get the verified emails from? And they say this special verification process, okay? So I'm going to model this as a function with an input and output. And the input is a regular old email address, and then also some sort of hash that is sent to you. And then the output is a verified email, maybe, okay? Because if the hash doesn't match with the email address or it's expired or whatever it is, I can't give you back a verified email. But if it does all match up, then I will give you a verified email. Okay, so let's look at the business rules now. We have this new thing called a verified email. We have this verification service thing, and we now have a choice in our contact information. So in order to create the unverified case, I can use any old email address. So if you've changed your email address and I don't have a verified email address, I can only create the unverified case because I can't create the verified case without a verified email. So if I want to create the verified case, I have to have a verified email. So where do I get a verified email from? Well, the only way I can get a verified email is the verification service, assuming that we have a private constructor and all that stuff. So in order to do that, I have to get it from the verification service. So the business rules have actually been enforced by this design. If the email is reset to an unverified one, it has to be unverified. And I can only create it verified if it's gone through the service. So I don't have to have any special documentation or anything to tell me what I have to do. Literally, I can't get it wrong because of this design. So we were talking about, can you eliminate unit tests? Yes, you can, because I don't have to unit test this anymore. I literally cannot write code with the bad thing happening. So let's revisit the what we have. So we now have a lot more stuff. We started off with one thing and we have 5 or 6 things now. Okay. But what's nice is that all these questions we had, what's optional, what's constraints, what's the logic, that is all clear. I mean, the optional stuff, we now have a special thing saying it's optional. The constraint types, we now have special things called email addresses and string 50s and verified emails. They have constraints which are now in the domain. Which fields are linked for concurrency reasons or for consistency reasons, that's much clearer too. And the domain logic about verified and unverified emails, that is now explicit rather than just being a Boolean flag. So what's interesting is that the code is a lot more complicated, you might think, but I actually think it's better because it's actually using the shared language that the experts are using. These are all concepts in the domain, and we are now representing them in the code. So if the domain is complicated, it's okay that the code is complicated. But the domain has a concept called a verified email. They talk about, the domain experts talk about verified emails. They talk about email addresses. They talk about personal names. These are concepts in the domain which we are now captured. And again, this is not just documentation. This is compilable code. And it's a really important thing when you do this kind of refactoring, called refactoring towards deeper insights. And what happens is often when you do some sort of refactoring, you learn things that you can use in other situations. So let's say there's a business rule that you can only send password resets to verified emails. Okay. Now, before we did this design, we might have logic like this. Says, you give me an email address, and then if the email address is verified, then I'll send a password reset. If the email is not verified, I'm going to throw an error because this should never happen. You should never be calling this function without a verified email address. And every time you see this should never happen, that's a bad thing because almost certainly it will happen. And, you shouldn't, if you can avoid writing this kind of code, that's best. If things literally can't happen, that's even better than having a message saying this should never happen. So this is the problem here is that you can send any old email address to this special password reset. Now, if in our refactored version, we have this new concept called a verified email. And in our send password reset code, we say, well, we're passing in a verified email as the parameter. And this is already verified. You don't have to test whether it's verified. You literally cannot call this function without a verified email. So we don't have to check anything. We can't possibly make a mistake. We forget to validate it. We forget to do something. And that whole thing of this could never possibly happen, literally can't possibly happen. I don't have to have a special error case for it. So this is really, really powerful. And we just learned something new. This new concept, verified email, might have a lot of uses in the domain. Right, so I'm just going to finish up with a few more things. This idea of encoding business rules with types is a very cool idea. And I'm going to show you that when you do a type-driven thing, it's a great way to handle domains that evolve over time. So we've now, in this thing, we've now got a new field, an address field, instead of just an email field. And because we have this new postal address, there's a business rule that goes along with it, which is that you have to have at least an email address or a postal address because there's some way of contacting you. Now, as it stands, this does not meet the requirements because as it stands, both of these are required fields. Remember I said everything is required unless you mark it as optional. Okay, well, let me mark them both as optional. Well, this doesn't meet the requirements either because they could both be missing. And that doesn't match. Now you could say, well, okay, they can both be missing, but I'll have some special validation logic somewhere that checks if they're both missing and throws an error. And I'm going to say that's a bad idea. So I want to model it in such a way that I literally can't have the bad case happen. Okay. So there's a quote, make illegal states unrepresentable, meaning you literally cannot write code that does a bad thing. So how can we do it in this case? Well, if you think about the requirements, a contact has to have an email or a postal address. Notice they're using the word or. Okay. What they're actually really saying is an email address or a postal address or both. 3 choices. But I'm using the word or, so that's a clue to how I'm going to implement it. All right, and there's 3 choices. So I'm going to use the word or to make a choice type with 3 choices. There's the hip. So here's my choice type, choice 1, the second choice, and the third choice. And the third choice has both of them. Okay. And then I stick that in my main contact type. So there's 3 choices, just like in the domain. And so the 4th choice, where they're both missing, is not a choice. It's not an available choice. I literally cannot write code with them both missing. That's not one of the choices available to me. So again, I don't have to write a unit test. I literally cannot write code that does something bad. So this is this thing, make illegal states unrepresentable, things that should never happen, rather than allowing them to happen in the code and then having extra validation logic saying, okay, this should never happen. If you can design the model such the way that you literally cannot even write the code, that's even better because you have less bugs and you have less unit tests. So the requirements are encoded in the type. So this is awesome. I think composable type system like this are almost as awesome as a cat on a unicorn. Not quite as awesome, but it's pretty cool. And a final thing I just want to point out is this kind of collaboration is a two-way street. It's okay for us to push back as developers. We don't have to just blindly accept everything that we're told, because you might say, well, that's the requirement, but is that really what the business wants? Because if I implement it the way I just did, it's awfully rigid. If I start adding another kind of contact thing, I'm going to have an explosion of different combinations, and it's going to get really complicated really fast. So let me push back and say, how about this? How about a contact must have at least one way of being contacted? So it's not quite the same thing, but it's I think it's a better way of thinking about it. So let's look at the better way of doing it, because what we do here is we say, well, here's all the different ways of being contacted. I can contact you by email. I can contact you with a postal address. And then I put those into a contact and I say, well, you've got a primary one and a secondary one, and the primary one is required and the secondary one is optional. So you have at least one way of being contacted. And it's not strictly the same because you could have 2 emails or something, but who cares? You know, it's much easier to model. And what's really nice about this, of course, is it's much easier to evolve, because if you add a new kind of contact information, you just keep adding to this list and you don't have to break anything else in your code. So there we go. So just to sum up, we've got the shared mental model in code. This is the most important thing. Really, as a developer, the best thing is if you can become a domain expert and use the same words and the same concepts that everyone else is using, rather than just accepting, you know, using technical jargon. It's really important to do this collaboratively. The idea is to get everyone on the same page using the same mental model. And designs will evolve. So I just want to point out, this is not a big design up front. This is a design where change is actually good. We want to welcome change because sometimes we refactor and we learn things through refactoring. We refactor, like with a verified email. When we did that, it's like, oh, that's a whole new thing that might make the rest of the code actually easier. And the nice thing about using a statically typed language is that it gives you a lot of confidence. If I make all these changes, like I say, this is the first file in the project. If I make these changes, the rest of the code breaks and doesn't compile, and I fix up all the compilation errors. And by the time I fix them all up and there's no more compilation errors, I actually am pretty confident that I caught all the cases. I'm pretty confident that nothing else is going to break. If I was using a dynamic language, I would be a lot less confident that I've caught all the corner cases when I change the domain. And finally, the power of a composable type system. So these choice types are really fantastic. I prefer them over inheritance. I prefer options instead of using null. I use a lot of wrappers for these constraint types, and I really try and make illegal states unrepresentable. So that's it, I think. We'll do some questions. I'm not stopped yet, but before we do some questions, I just want to give you some links. If you want this talk, I have a video of this talk and other versions of this talk on my website. And if you find this an interesting talk, there's actually a workshop next month. It was originally a 2-day in-person workshop, but now it's a 4-day virtual workshop. So you can come from anywhere all over the world to this workshop. And also I have my book if you're interested in a more in-depth version of this. So we'll stop there, and I'm also happy to answer any more questions right now.
Excellent, Scott. Thanks for reminding us about the workshop as well, which I would have done in a second. So yeah, we do have a couple more questions. So one from Thomas was, wait, let me find it. Yeah, it was written just after you started
Okay.
the last session. Sorry.
Okay, all right.
And that is, some things can be modeled with a type system suite. Others should be modeled with data logic, valid poker hand. Do you have a guideline or thought process for making a good decision on this?
Yeah. So as I was saying, that trying to document the rules of poker or something like this in the domain is quite hard. And if you do try to do it, you'll end up with something which is basically code, because, you know, trying to specify something to such a great detail, you're basically at that point you're writing code. So there's no hard and fast rules for this. You have to be flexible about how rigid you want to be and how flexible you want to be. So for example, using strings for first name, I might be fine with that, but I probably wouldn't be fine with using a string for an email. You just have to play it by ear. And if you make a mistake, the nice thing is if you make a mistake and you need to get stricter, you just change the domain and fix all the compiler errors, and hopefully, you know, it'll be easy. It's probably easier to be, I think it's just a matter of experience about, just like anything in programming. If you're too strict, that's too hard. But if you're too loose, that's bad as well. And where the right point is just a matter of experience. And it's a matter of, you know, in the domain, what you're working with. There's no, if there was an easy answer, I'd give it to you, but there never is an easy answer. So it depends. It's the classic answer is, it depends, is the only answer I can give you. So.
Excellent, as with many things in life.
Yes.
Then we have another one from Giacomo, which also was written in the last couple of minutes, and is, this approach is very explicit, as in good, safe. But what about more open domain models, generics or late binding?
Yeah, I mean, this is one way of doing it. I used to do a lot of Smalltalk, which is completely the opposite. And if you're doing domain modeling in Smalltalk, you'd be doing things in a different way. Like, for example, closure is functional, but and it has immutability, but it's a dynamic language. And so people in doing closure, domain modeling closure, tend to treat everything as like dictionaries or maps, key value pairs. Again, it depends on your language. It depends on what you want to do. Yeah, was that, sorry, did I answer the question? I'm not sure if that answered the question. I got sidetracked on thinking about Smalltalk here. Yes, late binding. See, anything to do with late binding is going to be a dynamic language. Or using interfaces. I mean, you can do interfaces in this if you have a behavior, rather than, this is a lot focused on data, but you can also document behavior in the same way, just like you'd use interfaces, a set of behaviors, and then the actual implementation of behavior can switch at one time on using late binding. So yeah, I guess one of the things I would say is I would focus on this. Again, it's not really the technical side of things, it's the communication side of things. The whole point of this is to communicate with experts to make sure you're building the right thing. So it's not so much about implementing the right thing, it's about being confident that you're building the right thing because you're communicating with the people who understand. And you're also learning yourself, you're becoming domain experts yourself by looking at this code. So it's not going to be perfect, but the goal is so anytime people talk about technical stuff about databases and stuff, I think that's, you're sort of missing the point. The point is it's about communicating with the domain experts.
Okay, excellent. Yeah, we see that Giacomo also wrote us in the chat that thanks, question answered.
Okay, good.
We have another one by Jonathan who says, hi Scott, I often hear people when explaining DDD warning against using full-on domain-driven design for everything. For example, you shouldn't use full-on DDD for this because it's just a side project.
Yeah.
Do you have a view on that or any warnings? I can't imagine that you would write your code any other way for a side project.
Yeah, I mean, again, if I'm writing a project for myself, the point of doing this again is to communicate with people. So if I'm writing it for myself, do I care? If I'm already the domain expert and I'm the only one reading the code, do I care about doing it this way? Probably not. But maybe if I'm writing code and I'm going to come back to it in a year's time and I'm going to forget what I was thinking about, maybe I will bother documenting it this way. Similarly, if I'm working with a bunch of friends and we're working on something technical and I don't care about, it's purely technical stuff and there's no other people I have to communicate with, that's fine. Like if I'm doing, device drivers or internal kernel, Linux kernel stuff, it's like, there's a whole different thing. But even if you're doing that kind of stuff, there's a shared domain language that people use when they're talking about technical stuff too. The other thing is there's some domains where it might not be appropriate. For example, if you're doing data science, if you're doing machine learning, almost everything you're working with is matrices of numbers. And, they're all numbers everywhere. It's hard, you can give them names, but you're not really trying to prevent you from making mistakes with matrices and stuff. And so I wouldn't really bother. I'll just use, it's not necessarily appropriate for doing that kind of thing. Maybe also certain kinds of other domains might not be appropriate. Like, I don't know, it just depends. It depends on the domain. Now you can mix and match. Like if I'm doing game programming or I'm doing, graphics programming, I might use domain modeling for the high end of it. But when I get down to the low end stuff, everything's just, graphic shade or something. I don't know how it works, but you don't have to use it for everything. Again, when should you use it? When shouldn't you use it? I don't know. There's no easy answer. It depends.
Okay, thanks, Scott. I think that is it. You've seen Scott's Twitter handle on the presentation. I'm actually going to share with you the slides of the talk that Scott has very kindly offered to us so that you can go back to the presentation if needed. And I think that's a wrap. So thank you very much, Scott.
Thanks very much. Thanks for having me.
It's been a pleasure. And subscribe to our channel. You should see the button down there. And we will see you all next week on Tuesday. We have Alberto Brandolini and Paul Reiner talking about how DDD is changing in the remote landscape and in the remote scenario. So don't miss it. 7 o'clock as usual. Thanks for being here. It's been an awesome talk. Thanks, Scott. We'll see you again next month for the workshop. And that's it. So we are learners. To the next one.
See you, everyone. Bye.
Bye.